Hey everybody, this is Larry. This is day 9, I think, I hope. If not, then, whatever. Of the Leetcode Daily Challenge, hit the like button, hit subscribe button, join me on Discord. Let me know what you think about today's poem. Right now, I am still in Helsinki, in front of the library, so, you should be studying. No, just kidding. But also, it's a very nice library, by the way. Apparently one of the attractions of the city. But also, I just want to show you this donut. I don't know if there's any... look. I just want to show you a donut, okay? But yeah, and now I'll give you a shot from earlier today. Boop. Hey everybody, this is Larry. Oh yeah, I had an intro. What did I do? Yeah, let's take a look at today's poem. We have count the number of balanced permutations. Still in Helsinki. I have to leave for the airport tomorrow. So tomorrow I probably will be a little bit of a late video, but today we have this video and that's good enough, right? Yeah, nighttime Helsinki. Anyway, all right, let's take a look. We have 3343, count number of balanced permutations. You're given a string num, a string of digits is called balanced. If the sum of the digits at even indexes is equal to the sum of digits at odd indexes. Return the number of distinct permutations of num that are balanced. Since the answer may be very large, return a mod. The permutation is a rearrangement of all the characters of a string. Okay. Hey everybody, this is Larry jumping into the editing. I was going to describe and explain my solution for this one earlier on so that you kind of get the explanation and then you can watch the live part later if you like. The thing is that I already solved this and I already have a video for this and I think I explained it pretty okay there. So what I'm going to do now, I think this is my first time doing this, and some part of it honestly is because I'm traveling, but also I looked at my old solution and I did it basically exactly the same way, but a little bit crappier. So I am going to edit in the explanation part of that video, and then I'll go over a little bit about what changed after that video, and then you can watch the live portion of how I solved it today live. Right. Sorry for a little bit setup. It's a little bit awkward. This is a very hard problem, and I am in Helsinki, so trying to get out of here and see the sights. Anyway, yeah. Thanks. Hey everybody, this is Larry. This is me going Q4 of the weekly contest 422 count number of balanced permutations. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one, there are two components. One is kind of breaking the problem down a little bit, and it just becomes dynamic programming. And then the second part is the combinatorial part, which is also a little bit tricky, and you have to know quite a little bit of math, both on the number theory and the combinatorial part. Not that much, but still, it's a lot of things to put together. Yeah, it's just... There are a lot of components to put together, and yeah, and that's all you have to do for this one. I think the dynamic programming one is actually the most straightforward. There are a couple of ways you can think about this one, right? Which is that the odd-even thing, right? The odd index and the even index thing. I think the way that I thought about it is that it's a variation on the tick no tick, right? And it's not a tick no tick. Then now. You just think about, okay, for each digit, for each number, or for each digit, is it going to be on the left side or on the right side, right? That's basically really the idea behind this. So that's the basic idea for the dynamic programming, is that, okay, if a number or if a digit is on the left side or the odd side, say, odd side, then what happens? And if it's on the even side, what happens, right? Pretty straightforward stuff. Well, okay, maybe not, I know. But at least, like, for the hard problem, that is how you would get started. And that's basically the way that I started. I don't have that code on me. I actually had it, I have it somewhere on the live version, but I actually modified this a little bit. The first question you may ask is that, well, doesn't the order matter? And the reason why you want to impose an ordering to it, and maybe there are different ways of solving this, just to be clear. Like a lot of these counting permutation problems, sometimes or very often even really, there are a lot of different ways to think about it and attack this problem. I'm just showing you my way. because they're just, mathematically a lot of different ways are equivalent, and a lot of people do a lot of smart things, and I'm like, oh, that's not the way I did it, but so I'm only showing you my way. And because, and for this problem, you have these things about permutations, right? And counting them. And so, yeah. So the first thing that I do for these problems with try to count the number of things and then permutate them is just, well, let's impose an order so that we can just count the number of times that happens, right? So for example, let's ignore the other constraints about it being balanced or something, right? So instead of just like, and you can actually do this, and maybe that's fine, but I didn't do it this way, which is that, instead of checking whether 1, 2, 3 works, and then 1, 3, 2 works, and then 2, 3, 1 works, what I did is that I always structure it from left to right. Impose an ordering, right? And what I mean by that, from left to right, is just really from 0 to 9, right? So I give an ordering, so I always do 0 first, I always do 1 second, 2 third, and so forth, right? And then once I impose that ordering, then now let's say I have just looking at one side, I still say odd. I mean, I say left and right for odd and even, but it's the same idea. Which is that then now, let's say you have something like this, you have 1, 1, 6, 8, 9, and keeping in mind that because we go left to right, meaning from smaller digit to larger digit, this is always going to be sorted, right? And because this is always sorted, there's always going to be one way. So then now it becomes, in theory anyway, that's my logic, is that now we can just count all the permutations of this, right? And of course, in this case, I'm not going to go over the mathematics of this part, honestly, that much, just because there's a lot to go over. And I think this part is the easiest to self-learn, because this is probably what people teach in, like, I don't know, at worst high school or something like this in math, like in terms of combinatorial, and figure out how the number of unique permutations, right? Or distinct permutation, I think is what they call it. Sorry. And what I mean by that is that 1, 1, 6, 8, 9, it's going to be, like another permutation is 1, 1, 8, 9, but you cannot swap the 2 ones because they're the same, right? And the way that this is just, it's going to be, for this particular number, it's going to be 5 factorial over 2 factorial times 1 factorial times 1 factorial times 1 factorial. And the formula really, and I'm not going to prove this and derive this. You can probably Google some of this, because like I said, this is very basic stuff, so I'm not going to focus on it. But basically, given that you have, let's say you have n elements, right? N elements, and you have, say, I don't know, d distinct objects, and or d distinct types of objects, each not differential, or like each not differentiable, or like each object of the same type is the same, right? Then and then now, so and we have, say, I don't know, we sub 0 of object 1, or object 0, keep it consistent, Larry. And we sub of object 2, right, dot dot dot, right? Then now in here, the number of distinct permutations is going to be n factorial over v sub 0 factorial times v sub 1 factorial times v sub 2 factorial, dot dot dot, right? So this is just, like I said, I'm not explaining this part that much, because this is math that, like, this is basic combinatorics, and like a whole lesson could be spent on this, so I'm not going to focus on this part, right? So okay, so yeah, so that's the number of distinct permutation, right, for a given number. So okay, so then now, how do we figure this out, right? Well, now I think we can talk about, or now we can look at the code. Okay, So I did a couple of things here. I just want to, focus on that part. But yeah, first we do the mod. We have an array of all the numbers. I just kind of convert it to a number, digit by digit. I don't know. I don't think I used this other than like right here. So okay, fine. But yeah, n is the number of elements in the array. I also don't use n actually. Well, okay, I use n to check whether we have number of odd digits or even digits, right? So here. I have the frequency table. So this is a, f sub I is equal to the number of times the digit I appears in num, right? So that's just the frequency table, pretty straightforward. This is the factorial mod things. I'm not going to go over this too much either. Fact sub I is just equal to I factorial. That's basically, modded, right? And I fact is equal to 1 over I factorial modded. And there's a lot of math about modular congruences. I think that's how you would I think that's yeah, and division, right? So another thing that you may consider looking at is just modular arithmetic division, right? I'm not going to go over why this works, even though it is actually very easy in Python. You could see you could see the code, but suffice to say that under mod you can't just divide a number, right? So we have this formula here, right? So you can't just say let's say mod is equal to 10, right? You can, and if n is equal to 10 factorial, well, if the top is equal to 10 factorial, bottom is equal to 5 factorial, right? Well, 10 factorial is, I don't know what it is, but 10 is in the number, so that mod 10 is going to be equal to 0, right? And here 5 factorial is there's a 5 times 4. 5 times 4 is already 20, so that means that mod 10 is also going to be equal to 0, right? So if you just look at 10 factorial mod 10 over 5 factorial mod 10, this is going to give you a bad time. So what happens is that there's this branch of math, and if you Google for modular congruences or modular arithmetic division, it will show you how to figure it out with inverse modular functions. The actual, there are ways to do it with basically the extended ORLIT function and stuff like this. I'm not going to get into any of that because, again, this is... So there are 2 lessons if you haven't done it yet. One is just, this formula for combinatorics. And then the second is all this stuff with modular math. As I said, this stuff, I don't know. If you don't know it, if you don't know it, then you just have to know it, right? And I mean that in the way that there's really, you're not gonna derive this part during the contest. This part maybe you can come up with during the contest if you're a little bit rusty and you could kind of think it through. But this part also, honestly, you're probably not coming up with this during the contest, so you just have to learn it if you want to be good enough to solve this problem. It is what it is. Also, maybe this is a good time to add that I probably do not think you will see this on an interview. Maybe I'm wrong. Maybe you're doing an Indian or an interview in India where they do ridiculous problems. But outside that, this is way beyond anything on interviews. So yeah. So that being said, then yeah. I'm going to skip this for now. We'll go back. Let's go over the dynamic programming, right? So then now, keeping in mind that I have a frequency table. So then now, index is actually the current digit that we are considering, right? And f of index is the count of that digit. And then now for this function, we go, okay, well, we have index. We already talked about what the index is. We have delta count. And what this stores is the number, the number of digits on the left minus the number of digits on the right? And you can maybe you could say that left digit is odd, right digit is even, right? Because I guess the first digit is always odd, is how they describe it, even though I think it's underspecified, as I said, but okay, right? So, so why is delta count enough? Delta count is enough because it also allows us to, one is that it allows us to compress state, but also we need to consider delta count because in an odd even thing, the additional constraint is that, well, there are two cases, right? If the number of digits is even, then you have to have the same number of digits, right? I mean, I think that's understandable. If the total number of digits is odd, then the number of odd digits is just one more than the number of even digits, right? I mean, I think also you could figure that out. And so this is something that we have to check because at the end, these are things that we care about. And what can delta count be, right? Delta count can range from negative 80 to positive 80, right? Because we only have 80 digits. And of course, you can actually bound this a little bit more just because, for example, if you had negative 70, you need 70 to get back to 0, so that's already impossible. So you could actually like do more if statements, but in general, yeah, so this has a 161 range or whatever, so that's fine, right? Delta sum is the same idea, but it's the number, the sum of the digits on the left minus the sum of the digits on the right, right? Or again, you could say that left digits are odd, right digits are even, right? So that's basically it. And from that, what is the range, right? Well, delta sum can go from, well, they're only 80 digits, so on the left side, it could be, let's say they're all 9s, then it could be negative 720 to 720. So this is only about like 1500, I round up, but 1500 range, right? And since index can go from 0 to 9, what are the number of possible inputs is roughly speaking 10 times 161 times 400, which is roughly what is that? Like roughly, well, 2.4 million apparently. But keeping in mind that a lot of these are not possible, right? I mean, maybe the negative 80 is always possible, but a lot of these sums, maybe they're all actually possible as well. I don't know. It depends on the input. But yeah. And each input can do a lot, and there's a for loop in there, so each input can take some time. But many of the states are not possible, right? And what I mean by that is, for example, if index is 0, well, your delta count is not going to go up because you only add and subtracting 0. So anyway, it's a little bit hand wavy, but there are a lot of impossible states. But this is also why this is one example that top down is better than bottoms up, because a lot of the states are not possible. If you try to do this with bottoms up, you're doing a lot of work over states that can never be reached, and that is just not as good, I think. But yeah, but with that said, let's go over the recurrence, right? These are kind of the things that I was thinking about during the contest. But yeah, so this is the base case. If index is equal to length of f, which is always going to be 10 because we always multiply by 10. I don't know why I wrote it this way. So you have two cases, right? Well, if delta sum is not equal to 0, then we return 0 because it's just not possible, because you need the sum to be 0. You need the left side to equal to the right side, or the odd digits. The sum of odd digits is equal to the sum of right digits. So if it's not equal to 0, we return 0. Otherwise, if it is odd, this is if it's even, I don't know. If it is even, then delta count can, then they need to have the same number of digits, right? So that means that you have to have the same number of digits on the left side and the same number of digits on the right side, or odd even. That makes sense, right? Because if it's not equal to 0, we return 0. Otherwise, then we can return 1. That means that if delta count is equal to 0, we return 1. Otherwise, if it is odd, if n is odd, then now delta count has to be exactly 1, because the left side, or the odd digits, have to be 1 more than the right side. So that's basically it. I think if you're consistent, it actually doesn't matter, but in any case, like if you could probably do -1 and it'll probably give the same, but Actually, I don't know if that's true, so I don't know. I think that is true though, because we don't even count the ordering yet, right? So yeah, so you have this return 1, right? Yeah. Yeah, and otherwise you return 0. Same idea, right? And then this is the crux of it. You have total is equal to 0. Fine. And then now for every number in the frequency table, that means that, okay, and I should write it here, right? So on the left side, we have, we put I index digit on the left, and then the rest we put on the right, right? Which is what we have on the right, which is f index minus I, right? Pretty straightforward as well, I think. And then we just count what happens. And this is the recursion, right? We go to the next digit. Delta count is equal to left minus right, because that's just the, we have now left minus right, so that's the contribution to the delta on this part. Delta sum is the same, except for it's left minus right, times index, keeping in mind that ordered index, or index is the digit, and we all have it all the same. So if we have, more on the left or more on the right, then we just count it by digits this way. And then we times it by this thing, right, which I'll talk about in a second. But this is the key part of the recurrence. And then we just make sure that we mod it, because we don't want to get it, we don't want it to be too big. And then we just return the mod again, because I don't know, you can never mod too much, I feel like. And then we kick off with the digit 0, the delta sum is 0, or delta count is 0, and delta sum is 0. And that's basically it. Okay, so why do we have this numerator and these I factor things, right? Well, so the idea here is that, okay, let's say we have, I don't know, and they may not equal the same, but let's say we have, one candidate answer. Let's say this would return 1, right? Where's the return 1? Let's say we return 1 on something that looks like this, and they probably don't sum to the same, so just forgive me. It's just to kind of demonstrate, right? Well, we have a number like this. Well, we look at every other digit, right? Let's just keep it even for a little bit easier, right? We look at every other digit, right? So then now you have 7, 5, 8, 1, 3, 6. That's terrible. And then 8, 2, 3, 8, 4, 1 on the. So this is what I would call the left odd portion, and then this is the right even portion, right? Okay, this is a terrible example because we don't have enough duplicates, but let's say I'm going to just change this to 8, 8, right? Whatever. So we have 4 8s, right? So then now, that means that, well, when you combine them, what is this? This is when this number, and let me change this real quick. I think I messed up. Okay, fine. So it actually is this one and this one. But in any case, so let's say, and this is when you take it out, right? So we have, this is the left side, this is the right side, and you combine them to get this number, right? Well, how many ways are there to permutate all these numbers here? And I actually messed this up on the example, because it should be sorted, because I think the way that we constructed it is sorted. So maybe okay, let me retry it real quick. So maybe you have like, okay, 0 0 1 1 2 2 4, something like this, right? 0 2, I don't know, whatever, right? And let's say they sum to the same, even though it doesn't make sense. And then now, if you want to create one number from this, you would take one from the left, one from the right, 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 one from the left, one from the right. I may be off by one or something, but you get the idea anyway, right? So how many ways are there to permutate this, right? Well, the thing is that the left side permutates by itself, right? And the right side permutates by itself. And what I mean by that is that, like you can basically, shift around all the digits here and shift around all the the digits on the right, but they do not combine, right? Meaning that you cannot change, like this 5 will never be on the left side for this particular answer. So you cannot swap the left and the odd and the even indexes, but all the left are within itself, right? And as we said, well, so then how many ways are there to permutate this, right? So the way to permutate this will actually be just, well, the number of ways to permutate is just the number of ways to permutate left multiply by the number of ways to permutate right. I mean, it's kind of hard to see because they're interleaving, right? But another way to think about it is just, okay, let's say we have the left digits as this and the right digits as this, and that's it. And then now you can permutate anything you want on the left and permutate anything on the right. Then now they're independent of each other, so it's just the number of ways to do the left times the number of things times the number of ways to the right? And the number of ways to the left is going to be equal to, as we already did it, it's going to be n factorial over all the whatever factorial, right? Like v sub 0 factorial dot. And in this case, this is how many numbers is it? 2, 4, 8, 9. Yeah, this is going to be 9 factorial over 2 factorial, 2 factorial, 3 factorial, 2 factorial, right? And then on the right side, this is also going to be 9 factorial over 1 factorial, 2 factorial, 2 factorial, 1 factorial, 3 factorial, right? And this is basically the idea. So then now, for each number that it is a right answer for, instead of returning 1, we would return this, right? We would return this times this is the number of ways to have this one answer, right? Yeah, right? So then now, the tricky part though, of course, is that, well, you can't really just blindly multiply by a number. Why? Because, let's say you have something like, I don't know. This is kind of tricky to do. Like something like this, maybe. Yeah, I don't know. But basically, it's hard to come up with a case off my head, honestly, such that the math is right. But pretend you have something like this, right? And maybe instead of doing every other digit, we'll just do the left side and the right side. Something like this. And of course, I forget that one will be in the front. But say you have something like this. This number will actually be different from if, like, maybe if you have a 2 here and a 1 here. I don't know. Right? But you can see that, okay, so this isn't actually a possible answer per se, but in a similar way, though, you can see that in here, the left side is going to be 4 factorial over 1 factorial times 3 factorial. Same thing for the right side. But if you have a possible answer that's actually like like this, then on the so this is this times 4 factorial over 1 factorial times 3 factorial, and then for this one, you would actually get 4 factorial over 4 factorial, there's only one unique way, times 4 factorial over 1 factorial times 2 factorial times 3 factorial. Oh, no, that's it, right? 1 factorial, right? So you cannot, so that means that this factor is not the same for each possible end result, right? So if you have an end result that is different, it will give you a different response, right? So that's why. And this is actually the last hard part that took me a little bit of time to figure out. And so then I was able to visualize this after a little bit, and I was trying to figure out, well, the thing is that I think the way that I thought about this problem is just trying to figure out how to it's just to figure out how to get the denominator, right? I think the numerator is actually, like, if you look at these things, the numerator is actually straightforward, right? It's always going to be 4 factorial, or if there's an odd number of digits, so let's say there's 7 digits, then it's going to be 4 factorial times 3 factorial, right? So then now the question is, how do we get the denominator? And the denominator, and also just to be clear, this is what this part is that we kind of jumped over before. If it is even, we just have n over. Oh, sorry, Yeah, I didn't say n, but n over 2 factorial times n to the n over 2 factorial. If it's odd, then we round one of them up, and then, you know, same idea, you get it. But then the even is that how do we figure out how to do all the unique values together? Well, this is why if you look at the live portion of me solving it, I actually rewrote parts of this to kind of, so that we get the or at the same time, right? As luck as we had it, I is the number of things on the left, and well, f minus I is the number of things on the right. And so on the numerator, we just keep track of this, so we times it by the numerator, and then on the denominator, we factor this in by having it here. And what this does is that basically it takes the count, and then we divide it by the number of unique things that is on the left and the right. And this factor basically is saying on this part, we want to add the contribution to, you know, so let's say, I don't know. So in this case, we have 6 2s, right? So if we have 6 2s, if we put 3 2s on the left side, we also put 3 2s on the right side. So then now we just take this out, and then we have 3 factorial over 3 factorial, and 1 over this, right? And this is why this is an inverse factorial, which is how we have it, or modular inverse factorial, something like this, right? So this is basically what we were adding in as we do this count as part of the contribution. And that's pretty much it. It's very hard, honestly. I feel like I don't know how many people end up getting it. It seems like 365 people. The contest just finished. But yeah, so I'm gonna go over. But that's it. I'm gonna show the code all in entirety once again, and kind of briefly go over it very quickly. So yeah, yeah. So you have my array, n, frequency table, factorial, inverse factorial, numerator, denominator, and then just dynamic programming over the frequency table. And that's pretty much it. Yeah, I'm gonna leave it here. Well, actually, let me just leave it to the top of this code, and then the bottom of this code. I know I didn't go over that much on the dynamic programming portion, but I feel like if you don't understand the dynamic programming portion, you probably have to practice a little bit more on that part. It is a prerequisite for this. There are hard enough parts to this one already, so that's why I'm kind of skipping a little bit on explanation. I mean, to be frank, the explanation part is already half an hour. So yeah, so that's pretty much how I did it. Let me know what you think. Thanks for watching. Oh yeah, what's the complexity, right? Well, actually, we already talked about this. We kind of analyzed this a little bit. Like I said, there are a lot of like it looks really high in the worst case, but a lot of the states are not possible, which is why it is fast enough. And yeah, that's all I have for this one. Thanks for watching. Yeah, welcome back. So the only difference between the solution that I described there and what I did today is honestly just that that I use modular factorial. I'm not going to go over it in this video. I think in that video I kind of talked about it a little bit and how to kind of learn more about it. But that's basically it. So everything basically applies. We just either, and the only other difference is that here, I think I mentioned this actually on the live portion, so maybe I didn't, is that delta count, right, is just odd left minus even left, right? It's just the delta between the sides. So that's why, even though there is an extra dimension, or looks like there's an extra dimension, it's not a real dimension because that it just depends on the current digit that you're modifying. And then, yeah, even left can be defined as a function of the current digit you're modifying minus odd left or something like that, right? So it's a very easy change. And delta count we kept the same, so we're pretty Gucci. But yeah, otherwise this is or basically the same. It's written a little bit differently, but it is basically the same. So yeah, the crazy thing is that I don't actually do mod here at all, which is kind of nuts. But it's fast enough. It's faster even. So I don't know. The code is kind of wonky sometimes. But yeah, and I count down instead of up for the delta. I guess this isn't really counting up because it's a delta, so it's always gonna be 0. But yeah, that's all I have for this one. You could watch me solve it live afterwards, but thanks for watching. And I know this is a weird edit, but let me know in the comments what you think. All right, bye-bye. So, I mean, I don't remember quite vaguely this, but okay, n is 80, which is interesting. That means that maybe we can do something funky with like n cube, n to the fourth, something like that, right? I think, okay, permutation, right? So what does this mean? So the first idea is that the odds and even digits don't really matter. Or what I mean by that is that if you kind of separate out the odds and separate out the evens, then you just have to count how many odds digits you need and how many even digits you need, right? Or digits at odd index and even index, and then you kind of do them separately, right? Because yeah. So for example, yeah, because they don't really interact with each other, only in the sense that yeah, the sum matters, right? So for example, you may rephrase this as okay, you may rephrase this as if the number of if the sum of the odd digits is equal to k for some k, or what is the count of the sum of, and then you kind of match that with the count of the sum of the even digits and so forth, right? So that we can do, and we can also do that just by the number of digits, right? Yeah, and I'm trying to take a look real quick. Right. Yeah. So for example, okay, so n is equal to length of num, right? Then now odd digits. So odd, is it counting by the? I wish they told us what index it is. Because this form is a little bit underspecified because odd and even indexes doesn't like do you count from left to right, you know, right to left, least significant first. Is the first one an odd or even, because first or zeroth, right? So there are a lot of things that Leetcode's a little bit lazy on this one, but this one, okay. So it seems like the first one is, I guess the odd even thing doesn't matter that much, but as long as you're consistent about it. But it's still a little bit awkward, right? So I think I want to say odd is equal to, so the thing is that you want to divide them in half, but of course if you have odd number of digits, then someone has to get the extra one, and that's what I'm trying to figure out. And it is just so even is going to be n over 2, and then odd is just equal to n minus even, right? So those are the number of digits. And then, okay, if there are 80 numbers, right? If there are 80 numbers, what does that mean? If there are 80 numbers, that means that there'll be 40 on each side, right? At most. And that means that the sum will be at most 9 times 40, which is 360, right? So that's kind of an implicit constraint that you try to figure out in terms of the sum. So if we're trying to figure out the sum on the odd side and the sum of the even side, then that's what we can do, right? Give me a second. And I think I want to say that there is a balance in that way, in that there's a symmetry between odd and even now that you specify the number, right? Because then, for example, and I don't know if this is quite right in terms of complexity, I'm just trying to bounce off ideas, right? Is that I can do, say, for total, or for s in range of 0 to 9 times, so odd is the one with the extra one, so it's gonna be odd plus 1 or something like that, right? Then we can go, okay. yeah, if yeah, then then in this case, then we just count. So we have maybe a total is equal to 0. We have total. We count the number of odd numbers, right? So we go. And I'm just going. It's called count, right? Of odd digits. So we have odd number of digits, where we have to try to get to the sum s times count of even digits to sum s, right? And of course, we have to do the mod. And of course, we can be a little bit lazy with the mod just because we're using Python. But so you have to be a little bit more careful if you're not using Python, right? So this, I think, I don't know if this is complexity fast enough, but that would be a structure, right? And the idea here is that this is just a 360 loop. If this is all one, this is all one, this is going to be fast enough. But then now we have to do the other part. And again, for today, I'm not going to go over memorization. And I apologize, by the way, if this video is a little bit disconnected. Like if I'm jumping a little bit all over the place. I don't know how to solve this yet in this moment of me talking about it. This is live. The intention of these videos are always that it's going to be live. And I know, and sometimes people are like, oh, it looks like you always solved it. I'm like, okay. I don't remember this one per se. Maybe I have some memory deep in there from practice, but I don't remember this one, right? So that's why it's a little bit not as smooth as I would like, just because, well, I'm solving this live, so I don't know where I'm going to go. This may even be wrong, right? So explore with me, and I want you to kind of see my thought process that I'm going through, and I'm talking through my thought process, right? But yeah, but for this one, I'm not going to go over detail in how memorization or dynamic programming works. Obviously, you need to know that for a hard problem anyway. So yeah. So then here we have digits left, right? And then we have a total left for the sum. And then that is if digits left is equal to 0. Yeah, if digits left is equal to 0. If total left is equal to 0, then we return 1. Otherwise, we return 0, right? This is just the base case. And the reason why I think this, I mean, we'll see if this actually works. But and maybe I'm just wrong on a bunch of things, to be frank, right? Like this could be just totally wrong. So, and if that's the case, my apologies, because I can't predict the future. But anyway, just left. There's, as we said, there'll be up to 40, right? Up to 40. Total left is going to be up to 40 times 9, right? So that's 360, as we said. So what is that? 40 times 360 is 1400. So that should be fast enough, because here each core does all of 10 work, right? So that's 14,000 times 10, and that should be fast enough. And I didn't do that part yet, which is that we now just, you know, a regular algorithm with just like going from 0 to 9, right? And then here you just count digits. So we took one digit, and it is total left minus I, right? So this isn't quite right, but hopefully this is directionally right. And the reason why this isn't right is because we leading zeros is the short answer. But I just wanted to kind of see how it looks like, get a texture of things. 55 is definitely way too high. Why is that 55? Oh, it's way too high because I do not consider the numbers at all. Whoops. I just kind of brute forced all sorts of things. I kind of, okay. My apologies, I just woke up. That's my stories, I'm sticking to it. Okay, so this makes it maybe a little bit trickier, right? First, we want to put everything in a collection. Oh, then I can't do this. Okay, sorry friends. I wasted like 10 minutes of your time. You can't do it this way because you can't do it this way because now you have to keep states of what goes in the left and what goes into the right. My apologies. So okay. So for some reason, okay. So now we have to rewrite all this. Okay. So now I have to think again. But part of solving these problems is this kind of experimentation and just understanding these things. Right? Okay. So now I have shown you one way in which it does not work. Okay. I think I was thinking of a different problem or misread it or something. Okay. Okay. So what's next? What else can we try? Right? Well, I mean, okay. So the idea, the idea that I'm going to have is going to be just, yeah, like me playing with the idea is, I think, okay. Are there zeros? There are zeros. So zero is a little tricky because we have to worry about leading zeros, right? Actually, do we worry about leading zeros? Maybe not. I keep thinking about worry about leading zeros, but I think that's why I'm a little confused. But it seems like maybe it's okay. I wish they gave an example though. But anyway, so my first initial is that you can kind of if you can rewrite this dynamic programming, right? If you rewrite this as the current number, right? Okay, let's say we don't have this thing, right? We want to say we have an array is you go to int of x for x in num, and we want to sort it, right? So now we have sorted, and then actually I don't even know that the sorted matters, to be frank, but and we also still want this, right? And then now we just go we go through the array from left to right so that we don't repeat things, right? So that means that we have an index on the array, and then we have a left sum and a right sum so that we can match in the end. But you can also so you want something like this, right? But of course, to kind of reduce state, you can actually combine this into a left sum minus right sum delta, right? So maybe we just call it delta, which is the sum minus left sum minus right, or odd sum minus even sum, or whichever way, right? And is that good enough? I don't know. But index goes from 0 to 80, right? Delta in this case would go from, what did I say? 360 or something, right? So like 9 times 80, I think. 720, I suppose, in this case. And that should be it, right? And then it should be just tick, no tick. Right, so for each digit, So you may wonder, okay, let's say I do have this, right? How do we deal with the permutation? Yeah, it's just that for each, actually, can I deal with the permutation? I was thinking that I could deal with the permutation, but maybe I am wrong. I could deal with the permutation directly, or afterwards. But that's not quite right? Wait, let me think about this. This is a hard problem, clearly, right? So you have a left and you have a right. So if it goes left, then what happens? And if it goes right, what happens, right? It's basically the tricky part about the permutation is that you don't necessarily want the odd digits to stay in the odd digits. Because basically you want to permutate only the odd digits and the even digits, but then you want to, is that right? So, okay, so I'm just trying to do the math, right? And I'm really bad at math, so that's probably whatever. But the idea here is that, okay, so you have n factorial. That part is straightforward for all permutations, right? And then now, I'm thinking whether we should remove impossible ones or add back possible ones. Okay, so let's say we have the base case, this goes to 0, right? Then now how do we figure out how many permutations are there? Because the thing is that the way that we did it this way, because we did the sorting and we could do the index on the sorting, order matters, right? Wow, the math is really hard for me. Maybe it's just hard today. But what I mean by order matters is just that, like for example, we have zeros on the left side, and because we're doing all the digits one by one, either to the left or to the right, right? But as a result, how do you do the math on that? Maybe this is wrong, to be honest. And for those of you who thinks that I always solved it and already know how to, and remember everything, then clearly you're wrong, because I don't remember anything. So in this case, we go right. Do the math on that. Okay, there's just a lot of different types of math. Okay, so what's on the left? There's going to be left factorial. On the right is right factorial, multiply them. And then I want to say, and this is why I'm like a little bit confused, and I can't really, like, my math is really bad right now. I want to say it should be like left factorial, or I say left and right because I'm dividing it that way, but you can say like even factorial times odd factorial is going to be the number of total things, right? But it overcounts, so you have to divide it by, you know, the frequency stuff, right? But is that enough? Is that enough to solve the problem? Because now you have one case. Honestly, unsure. I'm gonna play around with this for a little first. This is clearly way tricky, right? I mean, this is what I would have wanted to write. I don't know how to do the deduping and permutation things, but this is kind of the thing that I want to write. Whether that is correct or not, I don't know. Yeah, okay. I mean, I'm gonna try it. I honestly don't know right now. My math is a little bit wonky, but okay. So let's say then we have like if index mod, if this is a even index, then we just put in a even. Then we just count of index plus 1 delta plus array sub index, right? And then else something like this, right? Is what I want to write, right? Right. I just want to write out something real quick instead of thinking about it and everything is just 0. Why does that not work at all? Like, it should give me something, right? Like, this should give me at least 1. Delta. No, I'm too lazy. Let's print it out. Okay, 1. Oh, then I can't do it this way. This is just wrong. Huh. Wait, no. Well, I mean, it is wrong, but I think I'm doing it in a dumb way. I'm like combining 2 ideas in a really dumb way. What we want is, okay, so we have the delta, right? We have now odd left, even left, and this may be too, honestly, we're getting to the point where it may be too slow. So I don't know, right? Here we want to just, okay, so now we put it on the odd or even, right? So, right? Right, so something like that looks a little bit better. And in this case, delta is 0 and odd left is equal to 0 and even left is equal to 0. Right, so something like that actually. Oh, whoops. And this is, did I say odd first? Something like that maybe. Okay, at least it returns an answer. We didn't do the deduping or reduping or whatever yet. That's why I didn't expect it, but yeah, and in this case we have to redupe the thing, right? And I think and I don't know if this is right, honestly, right? So the number of ways we can is this even fast enough? Let's do the math real quick before I more invest in it. Index is 80, delta is whatever, odd left is 40, even left is 40, right? So what is that? I'm putting on my calculator. 80 times 40 times 40 times 80 times 9 is 92 million, which is too slow, I think. But even left should be okay. Maybe that's fine. Maybe that's fine. Because I said 90 million, which is too slow, but actually odd left and even left and index, right? One of these depends on the other two, right? Meaning that even left is just a function of n minus index minus odd left or something like that. So I think they don't, it's not a real extra dimension, right? So if you kind of remove one, then it becomes like 2 million, which is still a little bit sketch to be frank, but at least possible. Right. And then now here, again, I'm doing this in a very wonky way because I want to prove correctness more than being correct in terms of timing, and like it may time out or something like that, and that's fine in the sense that I just want to prove correctness more than timing, right? And then now I want to say, okay, if this is the case, then we want to say we have odd factorial, right? So odd f is equal to factorial odd, and I know that this is too slow for whatever, but that's fine, right? And then the bottom is going to be the number of things, right? Distinct things, which is what we have this thing on. I should probably have a library on this, but yeah. Okay, so then now we have for v in f dot values, we want to say okay, so top is equal to odd f times even f, right? Or maybe just t for total. And then now t subtracted by factorial of v, right? And then this is just times t with the mod, right? Okay, let's give it a submit. If it times out, then we can optimize it. I don't want to prematurely optimize. Okay, wrong answer is definitely not something you could optimize for. Okay, 11 output is 0. Why would my output be 0? Odd is 1 over 1. So t is, no, that's just 1, 1, 1, right? So, okay. Oh no, this is 2 factorial. So that's wrong, because this makes it 0, that's why. So this math is wrong. Okay. Huh. Because how do I limit this? Huh. This is what I was worried about, but I couldn't figure out a counter case in my head, and now I'm given a counter case, right? But which is that how do you permutate only within the odds and the evens, but also remove the dupes? But the dupes are kind of overlapping, right? Like in this case, I guess this is how you do it, because if you just permute the odds and the even digits, then you have odd factorial times even factorial. But then the dedupes of the ones, they yeah. Maybe that's fine, I don't know. But you have to dedupe them separately, which is why, so this is why this is wrong. Okay. Um, hmm. How do I do the crossover? That's the part I'm trying to figure out. Hmm. Hmm. Maybe I don't have to. Maybe I just have to do the parts components. Maybe I'm overthinking it with deduping across different things. Are they different? No, because you're permutating within the group. So okay, so you're only permutating the number of things on the left and the number of things on the right, right? So then how would that happen if we are able to separate both the left or the right? Well, we separate both the left and the right by so instead of well, this is just wrong, right? Well, I needed to charge my phone, so I guess this is making it almost charged. okay. If we do one digit at a time, how would that work? Or not one digit at a time, that's what we're doing now. If we do one number at a time, how does that work? Right? Can I do it that way? Does that make sense? Okay. So if we do it one side at a time, maybe that would work. We just have to divide it out as we... So we have to kind of... Okay, fine, right? So, okay, so in this case, maybe we can do the base case as... yeah, okay, so total fact. Again, we'll worry about the mod math later. I just want to kind of get it right. So so if we do something like this, right, and then here we do, okay, right, recurrent. That means that we're done with all the digits, and then now we just take, okay, so the current digits or the current number digit that we're doing, then we have f of current. Actually this is in string, so maybe we'd actually want so this is the number of things that are in the current number, right? Or number of frequency of the current digit, and then as a result, then we can just do like for I in range from this inclusive, right? And that means that we have either odd left or even left, right? So odd left is greater than you go to I, and even left is greater than you go to this is annoying to write. Because basically we want I on one side, and then oh, it's not, okay, yeah, oops, I guess I messed up. I was thinking n minus the total or something like this, but yeah, so okay, so basically we want to put I on the left and then the rest on the even, right? So if this is the case, then we want to say t is equal to count of current plus 1, so we could try the next digit, delta plus I times current minus f of current minus I times current. And you could simplify this, of course, right? But I'm just going to keep it dumb for yeah. And then odd left minus I, even left minus f current minus I, right? And then now this is the top, right? But then now we have to divide them out. So we want to divide out factorial of I and also factorial of f current minus I, right? Yeah, and then we just return total. And of course we mod it. Does this make more sense? Okay, this is... I'll explain the math in a little bit if I could get this. I should put this though. I should put that case in there. This is just really wrong though. I should put the other one. What was it? 1 1. Okay. That's unfortunate. I mean, I don't even know how to debug this, right? We could come up with a little bit better examples, maybe. Because basically the idea that I want to have is, okay, we don't do the left side and the right side, right? And I wish I have a drawing pad because it's so much easier, right? And then now we just calculate the left side, right? So the left side permutation is going to be And I say odd and I say left and right as in like because I'm separating out the odds and evens. But the idea, okay, let's just say focus on the odd side, right? Then the odd side is going to be odd factorial on top, that's the number of digits, and then the summation of all the different distinct things, right? Or not the summation, the product of all the number of things, right? So v sub 0 factorial, v sub 1 factorial, and so forth. And then now we know that the end result, we have to times this by even factorial over you know, their distinct things, right? I don't know, let's call it W, I don't know. And so then now we're just combining them together. And deduping it, but I don't, what case did they say it was? Oh, oops. Apparently I was much smarter about it. So I mean, 599 cases is a lot. So I'm trying to think whether it is just me doing the math wrong, or is it like, I don't know, they have 598 week test cases, or am I just like, you know, maybe like I'm off by something somewhere. But I have a mod here, so it's not mod related, I don't think. This part is a little bit sketch, I think, but let's see. Nope. Okay, so this part is the sketchy part, right? Because this should never be 0. If this is less than 0, then that means that this is bigger than whatever this is returning, which is definitely not what we want. Oh, actually, no. I think, okay. I think maybe if I remove this mod, it'll be okay. So it is maybe a mod math issue. No, okay. Yeah, okay. So now that we don't do any mod, this should never be true. So, okay. Because before, I think I messed up on the mod math. Maybe I need to do some inverted math stuff, but that's besides the point. Okay. Total, I guess. No, not total. T. Yeah, that's a little bit weird. The T will be 0 anyway. Okay, so it put 0, 0. Oh. That's weird. Oh wait, this is failing on the first case. Okay. Oh, I guess T could just be 0. So if T is 0 to 0, continue. Just save some math. Oh, huh. So maybe it was mod math. I know that this may time out, but I just want to see for correctness sake, right? And then we'll go over the math. And it doesn't time out, which is actually shocking, because then what we want to do is actually do math, but I'm not going to fix it for now, because it's already 40 minutes in. I'm going to explain this far. That's pretty tricky, though. What did I fix again? I fixed the mod because I had this over mod. That's why I was like, 599 is a lot. Okay. Yeah. Okay. If you're watching this live, or not live, but if you're watching this to this point, I am going to re-record the explanation. So you probably already saw the explanation because I'm going to do it in the beginning. But yeah, thanks for watching, Dan. If you're watching it up to here, though, let me know in the comments what's your. I'm here in Helsinki. It is Leetcode. Let me know in the comments what is a code place you would like to go. Just to kind of like, for me, it's a fun way for me to kind of see if who's watching it all the way through. But yeah, thanks for watching. Thanks for the support. Give me some love. I'm on vacation and I'm taking 40 minutes plus probably another 10 minutes at least of explanation on this problem. So yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. And yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.